Hello class, this video is about reciprocal trig functions, and so reciprocal trig functions are the reciprocal, taking a over b and flipping it to become b over a, of the SOHCAHTOA values. So these are reciprocals of SOHCAHTOA. So you already have learned that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Now if we take each of those and flip them, we get their reciprocal values. When you flip the sine, 1 over the sine is the cosecant. So cosecant is 1 over sine, and that means that the cosecant is the hypotenuse side over the opposite side. And cosecant is abbreviated like this, CSC. That means cosecant, that's the flip of sine. 1 over the cosine is called the secant. Okay, the secant is 1 over the cosine, and it is hypotenuse over adjacent. So hypotenuse over adjacent, and secant is abbreviated SEC, secant. All right, and then lastly we have the cotangent. The cotangent is 1 over the tangent, and that means it's adjacent over opposite, and the cotangent is abbreviated COT. So cotangent's the easiest one to remember. Make sure you don't get these two confused. The cosecant goes with the sine. The secant goes with the cosine. Okay, as we do these examples and these types of problems, I just wanted to review some of the tools that you guys already have in your tool belt. One of them being the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. We use the Pythagorean theorem to find the missing side of right triangles. The key words there being right triangle, okay? The Pythagorean theorem only works for right triangles, and the Pythagorean theorem is finding the sides. We use SOHCAHTOA to find the angles, but if one of the sides is missing, we can use Pythagorean theorem. All right, and another tool, the inverses. We can use the inverse sine, written like this, or the inverse cosine, or the inverse tangent, and they have the little negative ones here in the exponent. So those are inverses, and those cancel sine. So inverse sine cancels sine. Inverse cosine cancels. Those cancel them. And what do we use it for? These are used to find the angle. Whenever we're missing the angle, okay, on the inside of the cosine part, right in here, we have to use inverse to solve it. So if it looks something like this, okay, we have sine of x equals 42, and we're trying to get the word sine here to cancel on both sides so we can solve for x. What can we do to both sides to make sine cancel? In order to make sine cancel, we do inverse sine, and that will let us find the angle. When you do the inverse sine of both sides, the sines will cancel and you can solve for x. So we have our inverse sines and we have a Pythagorean theorem. Now let's look at a quick example. So in this example, let's see if we can find all 6 trigonometric values for this triangle, okay? And I'd also like you to find the missing angle. Okay, so let's see if we can find the things that I just asked us for. So in order to do that, we're going to look at this triangle and we're going to go, okay, in order to find the sine, let's go ahead and label our sides here. Which one is the opposite hypotenuse and adjacent side? Okay, well here's my 90-degree angle. So directly across from my 90-degree angle, that means that this is the hypotenuse. Okay, and this is the side that's touching the angle. So this is my adjacent. And that means the side over here is my opposite, which is opposite from the angle. Okay, good. So now that I know that, let's see what my sine would be. My sine is the opposite over the hypotenuse. Okay, but I have a problem here because I don't know what my opposite is. So before I figure out what my sine, cosine, and tangent are, it looks like I need to figure out what the missing side of the triangle is. In order to find the missing side, I can do the Pythagorean theorem. I know I can do the Pythagorean theorem because this is a right triangle. It's got a 90-degree angle in it. All right, so let's go ahead and do that. I'm trying to set up the Pythagorean theorem. Which number should I plug in? There's only one that really matters, and that's the value of c. C has to be the side that's the hypotenuse. So it looks like in this case I know my hypotenuse is 50. Okay. And then it doesn't matter which one I let be A and B. Let's say 14 is A. So I've got 14 squared plus B squared equals 50 squared. All right, 14 squared is 196 plus B squared equals 2500. Subtracting 196 to the other side, we have B squared equals 2304. And then taking the square root to get the answer here, that gives us B equals 48. So that means that my opposite side is 48. Okay, so now that I have that, now I can answer the question. So the question is asking me, what is the sign? Well, the sign is my hypotenuse over, opposite over hypotenuse, so 48 over 50. Okay, I'm just following SOHCAHTOA right now. So according to SOHCAHTOA, my cosine is adjacent over hypotenuse. That's 14 over 50. And the tangent is the adjacent over the opposite. Tangent is the opposite over the adjacent, so 48 over 14. Okay, and all of those values can be reduced. Okay, now let's find my cosecant, my secant, and my tangent. Well, the cosecant is just the reciprocal of sine. All right, so the cosecant was 1 over the sine. I can just flip these. That would be 25 over 24. And the secant is the reciprocal of the cosine. So that would be 25 over 7. And the tangent would be 1 over the tangent, or the reciprocal of a tangent. That would be 7 over 24. Okay, great. And the last thing I asked you to do was to find the angle. Well, to find the angle, I just need to take this equation that I have right here and do the inverse. In order to find the angle, I do my inverse sign. So let's do the inverse sign. Let's take this equation. The sine of the angle is 24 over 25. And let's take the inverse sign of both sides. Okay, these are going to cancel, and I'm going to get my angle. Okay, and let's just write that clearer. We have the inverse sine of 24 over 25. Okay, and just put that right in your calculator, inverse sine of 24 over 25, and we happen to get for the angle 73.74 degrees. Okay, great job.